Okay, we're going to do 5.6. So I can move if I have two logs and equals a number, so it'd be nice if this was a single log so that I could write it as a power equation. So 3 can go up as a power, and this product, the sum of two logs is the log in the same base of the product. So I'm going to have 4 times x minus 1 to the third. The log of that equals 5, and so now I'm going to write it as a power. 2 to the fifth equals this. 2 to the fifth is 32 equals 4 times x minus 1 to the third. Divide by 4 and I get 8 equals x minus 1 to the third. To get rid of the third, I'll do the 1/3 power, which is the cube root. And 8 is 2 times 2 times 2, so the cube root is 2 equals x minus 1. Those cancel. So I add 1 and I get 3 equals x. Let's check. 3 minus 1 is 2. To what power did I take 2 to get 2? That's 1 times 3 is 3. And to what power did I take 2 to get 4? That's 2. 3 plus 2 is 5. And so it checks. This one, subtract. Same kind of idea, but now we're doing a subtract, so that becomes the log of 2x over x minus 3. The log of a difference is the log of the the difference of logs is the log of a quotient equals 1. So 10 to the 1, which is 10, equals 2x over x minus 3. Multiply both sides by x minus 3, and I get 10x minus 30 equals 2x. Subtract 10x, I get negative 8x equals negative 30. Divide by negative 8 and I get 38, which is 15/4, or 3 3/4, but no. Yeah, but I'm going to leave it at that, is x. Now to check this, I'd do log of 2 times that, so that'd be 30/4 minus the log of 15/4 minus 3. And if you type that into your calculator, you'll get 1. So this works. Now, next one. So this is a sum, so we're going to have log of x times x plus 2 equals 4, so 10 to the fourth, which happens to be 10,000, no, excuse me, ln. E to the fourth equals x times x plus 2. So we're going to get x squared plus 2x, and I want to make this equal to 0, so minus e to the fourth. And so I can plug that into the quadratic formula. Do I have that on this calculator? Yeah, quad form. There we go. So we've got a is 1, B is 2, and C is e to the fourth, a negative e to the fourth. And it tells me that it's either 6.456 or negative 8.456, something, blah, 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 blah. So, and ln x has to be positive, so it could be that. And 2 plus that would still be positive, so we can use that one, can't use that one. And you can plug that in and check. Should work. Okay? 45. I like these because they're easy. I want to solve for a power, so I take the log of both sides, and I can do it in base 10 or base e. I'll just write log base 10 of 8 to the negative x equals log of 1.2. The negative x comes down, and so then this is a number, so we can divide that into there as well as the negative, so we get x equals log of 1.2 divided by the negative log of 8. And that is log of 1.2 close parenthesis divided by negative log 8, and we get this number, which is negative 0.08767 blah, blah, blah. Now let's check that. So I'm going to store that into x, and now I'm just going to type 8 to the negative x, and it says 1.2. Alright, this one. So I'll take the log of both sides, and so I'll have log base 2, log a base 10 of 2 to the x plus 1, but that'll come down, equals 1 minus 2x log of 5. I take the log of this side, the power comes down. And these are just numbers. You can type those in right now if you want and get those decimals, but I'm going to just write, distribute this. So I'm going to have log, make sure you can see that. Yeah. Log 2 times x plus log 2 equals log 5 minus 2 log 5 times x. These both have x's in it, so I'll add that over here. So I'm going to have log of 2, whatever that number is, plus 2 log 5. Those would be all times x. This many x's plus this many more x's. And I'm going to subtract this over, so I'm going to have log 5 minus log 2. And so then I just take that divided by that. And let's get that answer. See, that'd be parenthesis, the numerator is going to be this, log 5 minus log 2. That's the numerator, close it, divided by, and the denominator will be parenthesis log 2 plus 2 log 5, close parenthesis, the denominator, and I get 0.23422. That's what x should be. I'm going to store that in x, and then I'm going to type in 2 to the x plus 1. Oop. Need the parenthesis in there. 2 to the x plus 1 is 2.35. Now take 5 to the parenthesis 1 minus 2x, close parenthesis, and I get exactly the same number. So I did it right. And finally, this one, which will work the same way as before, so it's going to be log of pi, and the 1 plus minus x will come down. Let's do natural log on this, because then this just becomes, if I take the natural log of this, they cancel out and I just get x. So I get ln pi times 1 minus ln pi times the negative x times a negative x, so I got the negative there, equals x. So I'm going to add this to the other side, so I'm going to have ln of pi equals x plus ln pi times x. So the x comes out, factors out, and I get x times 1 plus ln pi. And I can divide that over here, so I'm going to have ln pi divided by 1 plus ln pi. equals x, and let's just check that. So ln pi, close parenthesis, that's the numerator, the only one thing, so I didn't have to put it parentheses, over the denominator is more complex, that's 1 plus ln pi close parenthesis for the denominator, and I get 0.5337 stored in x. Take pi to the 1 minus x, close parenthesis, and I get 1.705. Now I'll take e to this same number, e to the x, and I get exactly the same thing, so this works.